Alright students, so in this video I'm going to explain this given trigonometric identity. Always remember you start with the complicated side. So you have two sides, left side and the right side, and you can clearly see that the left hand side is the most complicated side. So I will start solving with the left hand side. Clear? Alright, so left hand side I'm going to rewrite it's sine x over 1 minus cos x plus 1 minus cos x over sine x. Okay, so we can see that we have two fractions, right? So if we have two fractions, we will try to make same denominator. How are we going to do this? I will multiply this denominator with this term and also multiply with sine x with numerator, also with denominator. Clear? And I will multiply this term with this denominator. Okay, so it's going to be times 1 minus cos x over 1 minus cos x. Clear? Alright, now let's simplify. Once you multiply the terms, you will simplify them. So it's going to be sine squared x, because sine times sine means sine squared x, sine x 1 minus cos x. I will not distribute them, I will just keep them same. This one is going to be 1 minus cos x 1 minus cos x over sine x 1 minus cos x. As you can see, in these fractions we have same denominators, and once denominators are same, we can combine these two fractions, and it's going to be sine squared x plus, now look, this is parentheses, I'm going to distribute these parentheses. So first 1 times 1 is 1, 1 times cos x is minus cos x. Let me put the fraction, and the second one, negative cos x minus 1 is negative cos x, and negative cos x and negative cos x is going to be plus cos squared x, and denominator stays same. Clear? Alright, now I am going to rearrange the numerator. Sine squared x plus cos squared x plus 1 minus cos x and minus cos x will become minus 2 cos x over sine x 1 minus cos x. Clear? Now notice this part. This is Pythagorean identity, and we know that sine squared x plus cos squared x is equals to 1. Now this term will become 1 plus 1 minus 2 cos x over, again denominator stays same. Now let's simplify it again. 1 plus 1 is 2, 2 minus 2 cos x over, denominator stays same. Now in numerator you can see that you can take 2 as a common factor, and you will left with 1 minus cos x over sine x 1 minus cos x. Clear? Now we can cancel out 1 minus cos x and 1 minus cos x. You will be left with 2 over sine x. And we know the identity that 1 over sine x is cosecant x, this thing will change into 2 cosecant x. Now look, this part and this part, we got the right hand side. So we proved this identity. Alright, so next we have this question. We are going to prove this identity, and it's again, you can see that the left hand side is the most complicated one. So I will start with the left hand side, and it's sine x 1 minus cot x plus cos x over 1 minus tan x. So in this question, you might be thinking that again we have two fractions and we will try to make same denominator. Yes, you can also solve this question with this method, but the only difference is this gonna be a really long method, but still you can get your right hand side. But what I will prefer is I will use identity in cot x and tan x and then try to simplify it. So it's going to be sine x over 1 minus cot x is cos x over sine x plus cos x over 1 minus tan x is sine x over cos x. Now look, in this step, in denominator we have two different fractions. So we will try to make same denominator for those fractions. So just imagine here we have 1 over 1 and here again we have 1 over 1. So you're going to have sine x over, I'm going to multiply this term with sine x over sine x to make same denominators. Okay, cos x over sine x plus cos x over, here I'm going to multiply with cos x to make same denominators. Alright, now we have two fractions with the same denominator, and we're going to have sine x over, let's combine the denominators, it's going to be sine x minus cos x over sine x plus, here we have cos x over cos x minus sine x over cos x. Clear? Now look, according to the fraction rule, what do you do is I can take this term into the numerator and this term over here. Clear? So what do you do is will become sine squared x plus cos squared x over, sorry, no, you're not combining them, you will keep them separate. So it will be sine squared x over sine x minus cos x over cos x minus sine x. Alright, now we have two fractions again, but you can see that the terms are almost same, only the sign difference. We have a sign difference. Here we have sign positive, here we have sign negative, here we have cos negative, and here we have cos positive. So what do you do is I will multiply the second term with the negative sign, and if you will multiply with the negative sign, what will happen? It will switch the signs, so it will become sine squared x over sine x minus cos x. This will stays as it is, and this term will become minus, because we are switching the signs, you will get minus in them. Sin x minus cos x. Clear? Now what do? We have same denominators, and once denominators are same, we will combine them. It's going to be sin squared x minus cos squared x over sin x minus cos x. Clear? Now maybe some students are thinking that sin squared x minus cos squared x, so it's a Pythagorean identity. No. In Pythagorean identity, you have plus sign between them. You cannot use Pythagorean identity. So how are we going to continue this question? Let me remind you a formula, which is, I'm going to write it down here. A squared minus b squared is a plus b and a minus b. Now here, sine is presenting as a and cos is presenting as b. And if I will use this formula, this expression will change into sin x plus cos x times sin x minus cos x over denominator stays same. Clear? Now you can clearly see we can cancel out a term which is sin x minus cos x and sin x minus cos x, and we will left with sin x plus cos x. You can see this one and this one, they both are right hand side, so we prove the identity.